Okay, so welcome to Unit 6, Lesson 4. It's our second last lesson of this unit. We're looking at different functions and formulas today. So you will see a bunch of different formulas. We're going to specifically look at some like simple and compound interest, so it's just some finance formulas, but you may see some area, volume, surface area, that type of stuff in your homework. Okay, but your key here today is that you can manipulate equations to solve for unknowns and also identify the type of function you're working with. Okay. So I'm going to go through what your simple interest formula and your compound interest formula are, kind of what the difference of them are, because you'll see this in a couple of your homework questions. Okay, you'll see this is what I'm going to go through, but then in your homework, you are going to have a bunch of different equations and formulas that you may have to manipulate, which I'll go over at the end of this lesson after I go through simple and compound interest, just so you can kind of see the key ideas that you need for homework. Okay, so simple interest is calculated using the formula I equals PRT. I is the simple interest, so the amount of interest you make. Okay. Okay, your P is the principal or amount of money invested. So if you have $1,000, it'd be like the $1,000 you put into a savings account. R is the annual or yearly interest rate as a decimal. Remember, so if you're given 30% of something, to make it a decimal, you're going to divide by 100, which would be 0.30. So you're going to put that into the formula. You don't put 30% at 30 as a whole number in. And then T is your time in years, specifically years. Okay, so let's go over an example. Interest rates in the 1970s were much higher than they are now. Definitely, we would never get a 10.25% interest rate now. You're looking at more like a 2%, 1%, 0.5%. Okay, so suppose you bought a $500 Canada savings bond at that time. If you kept the bond until it matured, you received 10.25% interest per year for 7 years. Okay, so let's look at how much money you make per year. So here's year 1 to year 7. Your principal is $500 because that's the amount that you bought. So you're going to take $500. You're going to calculate what 10.25% of 500 is, and it's $51.25. So you're just going to add these. You're going to add these two together, which would give you your total amount, or you're just going to look at your total interest and you're going to add 51.25, add another 51.25, and it's going to keep going up from there. So at the end of those 7 years, you are going to have made $358.75 of interest. Okay, also, you could use the formula I equals PRT, and I'll show you that quickly because I think that's way easier and way more simple than this. So I is equal to, you're going to take your principal, which is $500. Your rate is 0.1025 as a decimal, and then your time is 7 years. If you put 500 times 0.1025 times 7 in your calculator, you get $358.75. So notice how much easier that is just calculating interest like that. Okay, either way though, if you use a table of values or the formula, you do get the same answer of the $358.75 for interest. Okay, compound interest, which I'll go over the formula in a second, but in a compound interest CSB, the interest earned each year is added to the value of the bond. So you'll notice the difference for compound interest. We start with $500 as our principal. Our interest is still the same, so $51.25, so our total interest is $51.25. However, you now, to get this total, this principal here, you go 500 plus the $51.25. So you end up adding you end up getting interest on your interest. You end up making interest on your interest, which is definitely a benefit for compound interest. I'll just write interest on your interest, which is good. I'll put a big check mark, which is good. You really want that. Okay. So then you have a new principal. So $551.25, which is just the 500 plus this 51.25. Your interest earned is now a little bit higher. So if you take 0.1025 of this $551.25, you get $56.50. So now you're going to add the $56.50 here to get $107.75. Okay, and you keep going down and getting that trend. So you'll notice after 7 years, you have more money. The amount of interest earned is $489.96 versus the $358.75. So if I asked you to compare between simple and compound interest, you would always say compound interest is definitely your more beneficial interest that you want for a savings bond. Okay. So if you're looking at simple and compound interest, obviously I just said the total interest for compound interest is higher. Okay, so CSB earning simple interest provides regular interest income but less total interest. The CSB earning compound interest gives greater total interest, but the interest is not available until the bond matures or is redeemed. This is the trade-off between simple. So if you're just wondering a little bit more about the difference between simple and compound interest, that explains it. Okay, so don't worry too much about that. I'm more concerned about those calculations. Okay, so again, looking at your simple interest, if you were to take your first differences for simple interest are always going to be the same. First differences for compound interest are not, which means this means that this is going to be linear. If you were to take your second differences, it might not be, but you know that it's not linear. Okay, so if we were to draw a graph, okay, you're going to get simple interest as a linear graph, where compound interest is going to start to slowly get bigger and bigger over the years. It's actually an exponential graph because you earn interest on your interest, so it's going to increase at a faster rate. Okay, again, don't worry too much about this, about the graph itself. Okay, just remember that this is why compound interest is going to make you more money in the long run because you make more interest. Okay, so for connecting our ideas, what we're going to do is now look at the formula for compounding periods and compounding interest. These are key if you have annual, semi-annual, quarterly, monthly, or daily for your interest, because remember that compounding periods need to be in terms of years, but if they give you it in terms of like months, then you're going to have to manipulate your interest and your time to reflect what is happening during a year. Okay, so here is an example for that to make more sense. Our general formula for compound interest, remember simple interest was I equals PRT. Our general formula for compound interest is A equals P1 plus I to the N. So your amount is your final amount, is that A. Your P is the same like a simple interest. It's your principal, the amount you're putting into your account. I is still your interest rate, but it's per compounding period. Needs to be annually. So you might need to manipulate it to make it annually. And then same with N, your number of compounding periods needs to be annually as well. And that will make more sense in an example. Okay, so suppose a principal of $1,500 is invested at an annual interest rate of 5% for 4 years. Okay, so what you're going to do, figure out what your P is. The amount of money you put in is $1,500. Your interest rate is 5%. So you take 5%, divide it by 100, and that equals that 0.05. And then it tells you for 4 years, so N is equal to 4. You're going to sub that information into your formula. So P1 plus your interest rate to the exponent 4. And then you're going to solve that. I'll put a middle step here. Remember that you are doing 1 point. You're going to add in your brackets first. And then you're going to do 1.05 to the exponent 4 first because of BEDMAS. And then you're going to multiply those and it will give you approximately that 1823.26. Okay, so you make your final amount will be $1,823.26. That is your total amount. Remember, if I asked you to find the interest, that's going to be your total amount. So your A and then minus your principal. So 1823.26 minus the $1,500, the amount of money you invested, would be $323.26. So your interest would be that. Okay, don't worry too much about that, but just making sense of what we're calculating. Okay, what about an example like this, where I give you the exact same answer or information, but I want it to be a semi-annual compounding period. Okay, if I want you to do that, you're going to have your P is equal to 1,500, but your interest rate and your number of years is going to be affected. Semi-annual is twice, 2 times per year, twice per year. Okay, and that was on the previous slide, or a couple slides ago, of different compounding periods. So what you're going to do is you actually have to find what half of that 5% is, because you're calculating it 2 times a year. So the first time it's calculated would be 0.025, and then another time it's calculated 0.025, which adds up to that 5%. Okay, so you just take half of 5%, or you're just doing 5% divided by 2. Okay, then you also need to, in 4 years, there are 4 times 2, so 4 years, you semi-annual, so twice a year, or 8 compounding periods, so you're going to multiply by 2 there. Okay, so your final answer ends up being 1,500, 1 plus 0.025 to the exponent 8, so still subbing in those answers. And then after 4 years is $1,827.60. So if you go back one slide, it ends up being a little bit more money to compound it semi-annually versus annually by a matter of like $4, okay? But still, money is money, right? So just making sure you always, a star here, you always divide. This is something important. So always divide your interest rate by your compounding period. And then you always multiply your years, or your N, by your compounding period. Okay, so just make sure that you know that, because that's your key there. You're never going to multiply your interest rate or divide your number of years. Okay, it's always divide interest rate, multiply your years. Okay, another example, so we'll go over that again using what I just said. Remember, divide interest rate, multiply years. What's monthly? How many times does months happen in a year? It's 12. Okay, so that is what we're going to use for our interest rate and our years. So principal is still 1,500. That's never going to change. Your monthly rate is 1 over 12 of 5%. So you're going to take 0.05% divided by 12. Like I said, you're dividing by your interest rate. And then you're going to get a funny or a big number there, which doesn't matter. So you can either keep this as a fraction and plug it into your equation as that, or you can put it in as the big long decimal of 0.004166666. Okay, then your not your interest rate, your number of years, I told you to multiply. You take your 4 years, which is given in your equation, multiply it by 12, which is 48. So your number of compounding periods is 48. The number of times that you're going to pay interest is 48 times in that 4 years, because you're doing it once a month. Okay, so again, sub those numbers into your formula. Easy enough there. And then you're going to get 1,831.34. Make sure that you're attempting this on your calculator so that you can get the same answer there. Remember, do 1 plus this fraction to the exponent 48 and then times it by 1,500. Make sure you're doing the correct order, okay? So make sure you're able to get that number there. Again, compounding monthly gave us even a little bit, $4 even more. The last one was 18.27 for semi-annually, so you're making even more money when you're compounding per month, okay? So one more example using these two these formulas and these different compounding periods is Terrence wins a contest. The prize is a $1,000 bond that matures in 5 years, but he has a choice of 2 bonds, so 2 different interest rates and 2 different compounding periods, and we want to choose which prize he should choose. Obviously, we want the one that makes us more money. Okay, so for bond A, you have your principal is $1,000. It tells us that right there. You have 0.085, which is your interest rate, and your compounding period is 4. So you're going to divide your interest rate by 4. I told you to divide your interest rate. Okay. Then you have your number of years, which is 5, and you're going to times your number of years by 4 because that's your compounding period to equal 20. Then you're going to substitute that into your equation, and you should get an answer of $1,522.79. Okay, so again, divide your interest rate by your compounding period, multiply your number of years by your compounding period, plug it into the formula, and solve. Okay, then looking at our 8% compounded monthly, that is 12 times a year, still using the principal of 1,000, still using that 5 years. You have principal of 1,000, 0.08 this time, not 8.5 because it's an 8%. Divide it by 12 because that's monthly, and then 5 times 12, so you get 60 compounding periods. Plug it into your formula. The amount of maturity is $1489.85. So the one that gives us a better interest rate is bond A. If you go back, $1522.79 or $1489.85. Well, bond A, it gives us our greater amount, so that is what I would want to see from you. Okay, so some key ideas for homework. So there are some examples. You will see some simple and compound interest in your homework for today and tomorrow. Okay, some key ideas though for some of these questions, because I can't go over all the questions because there's so many different formulas that you can rearrange and you can find for. Just some key ideas: rearranging a formula to solve for other variables. Follow SAMDEB. Remember, that's subtract and add in the order they appear, then multiply and divide, then exponents, and then brackets. Okay, that is, if you've never heard that before, that's just how you rearrange a formula, but it's BEDMAS backwards. Okay, so that should help. So look for things to get a variable by itself, look for things to add and subtract or get rid of first. If you can't add or subtract, then go on to multiplying and divide. After that, look for exponents and brackets. Okay, this is your algebra skills huge. So if this is something that is a little bit weaker for you, make sure that you're asking me lots of questions, okay? Because there will be this stuff on your test. This is your last unit test, okay? Rearranging a formula to solve for other variables. Remember, so using, like, it kind of goes hand in hand with SAMDEB. So if something is added on one side of the equation, so like let's go x plus 3 is equal to 8. Remember, if something is added on one side, you have to use the opposite operation to get it onto the other side. So the opposite operations are addition, subtraction, multiplication, division, squaring, square rooting, cube rooting, different things like that. Okay, so make sure that these kind of go like hand in hand together. So to make sure to add or subtract and get something to the other side of the formula, you're using that opposite operation, or to multiply and divide if something's multiplied already, then divide it to get it onto the other side of the equation. Okay, and then to solve for a certain variable, substitute the given values into the equation and solve for the variable using the strategies given above. Okay, so sometimes it'll give you an equation. It just says like if your radius is 5 and your diameter is this, what is the circumference? I mean, that's not a question, but if it says that, you're just substituting the radius is 5, you're substituting a 5 in for the r for the radius, and then you are going to solve for the variable using the strategies above. Okay, so just some key ideas there. Just make sure that you are following SAM-DEB totally and using your opposite operation. Okay, let me know if you have questions. Your homework is page 121 and those questions there. Let me know if you have any questions, and good luck.